Foreign object detected. Does not compute. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Hi. So each year I try to come up with something new to show off at the Hackgame booth at our local Maker Fair. The next Maker Fair is less than 1 month away. It's being held in August at the Trondheim City Centre. So and this year I came up with these two guys. So I'm not sure if you can tell, but it's supposed to be a replica of the XBOT 4000 robot from the Netflix series Love, Death and Robots. And I'm pretty used to just 3D print stuff, add some electronics into the mix and do some programming, and then I'm done. But this time I actually had to do some manual sculpting. So I thought, how hard can it be? And it turned out to be pretty hard, since I'm not an artist. The original was made in monster clay, and I then made a brush on mold using smooth on rebound 25. It's like 4 layers of silicone. And I added silicone thickener to make the outer layers thicker. So the inner layer preserves details and the outer layers provide rigidity. And the outer shell, the mother mold, is just plaster bandages and plaster. And I did 2 castings from this. I used a 2-part casting resin called Formcast Bureau, which has a pot life of only 3 minutes and a demold time of 10 to 12 minutes. So it was quite easy to do the slush casting or the rotocasting. And then the models were painted using just Warhammer paint, and I did some weathering on this one. And this one is just a layer of clear lacquer. So this one is just a static model. It has eyes or retinas that are as true to the original as I could make them. So I have light guides and a LED array backing the eyes. I plan to add some sensors to this as well. I'm planning to use a lidar, so that when the visitor approaches the booth I can trigger samples, sound samples, make it flash the eyes, etc. So I haven't programmed this yet, so we'll see what it looks like. In this one I have an animatronic eye mechanism. So the mechanism uses like 8 servos. And it has individual control of the eyelids, which makes it quite expressive. On top I have a camera gimbal. This is just a standard Raspberry Pi camera. So the idea is that I can use this camera connected to the Jetson, which is inside in every computer case. So this Jetson is going to run some form of face tracking software, probably MTCNN. The MTCNN will be able to locate faces and also landmarks within faces in the image. So I was thinking I can run this MTCNN and then just pick a face in the crowd and try to center this face in the image on the camera using the camera gimbal. And then these servos controlling the eyes could slave the camera gimbal and make it appear so that the robot's actually looking at someone in the crowd. I have no idea if I'm going to be able to make this work, but I'll give it a shot, so we'll see. Further, the dynamics controller is something called OpenCM 904. It's an old controller from Robotis. This will talk to the Jetson via USB, and I'll probably make a simple protocol for just controlling the eyes instead of letting the dynamics protocol through, since I suspect that the Jetson will be quite busy doing inference and don't have time to deal with the kind of latency requirements for the dynamics protocol. So that's it. I haven't done any coding yet on any of these, but I have verified that the electronics work separately. So I'll just dive into the compilers and we'll check back to see if I can make it work. So this is the development environment for the static version. It's running on a Raspberry Pi 4, which is hooked up to a transistor, so it can control the LED array. And it's also hooked up via I2C to the lidar sensor. This is the shell for the Raspberry Pi, and this is Visual Studio Code, which is set up with to do remote editing via SSH on the Pi. So here I have a small Python program, which is basically just running in an infinite loop. Takes samples from the lidar, and depending on the distance to the target, it will play different wave files. So we can try and run it and see if it works. So if I put something in front, put my hand in front of the sensor here, it should trigger a wave sample.
Citizens of the Earth, you will be destroyed. Self-destruct initiated. Have a nice day. Foreign object detected. Identification, please. Identification, please. Self-destruct initiated.
Whoops.
Have a nice day. Distance to target. Lock on target. Identification, please.
Before I move on to demonstrate the mechanics, we can take a look at the inner workings of the robot face. I had to do some reshuffling of the electronics and the mechanical assembly. But at the top we can see the Raspberry Pi camera and the two servos that control the alignment of the camera. And below this we have the OpenCM 904 controller and the OpenCM 485 expansion board. Now, I don't really use this expansion board for anything, but it's a really convenient way to provide power to the controller. The eye mechanism itself consists of 8 servos, which allows for individual control of each eye, and also separate control of the upper and lower eyelids. I ran into a couple of alignment issues, since the mech is 3D printed from a CAD model, but the face is handmade. So I had to add spring-loaded adjustment screws, and this allows me to tune the alignment of the left and right eye mechanism individually. There is a USB cable going from the controller to the NVIDIA Jetson, and this allows the Jetson to control the servos via a custom protocol. Since the transport is over UART, I should ideally have a framing protocol like HDLC, but I was so eager to verify this build that I made a temporary single byte command protocol instead, just for testing. And this lets me verify movement, limits, poses, etc. from a terminal emulator on a PC. Before we move on to the eye tracking, we can quickly hook the robot face up to a PC and test the protocol from PuTTY. Let's flip this around. I forgot to mention the firmware that's actually running on this OpenCM controller. This is a little program that I made to control the eye mechanism. It only took a few hours, a few hundred lines. So it basically has definitions for each servo. Each servo has its own unique ID, ranging from 1 to 254. I have a few commands for moving the camera left, right, up and down, etc. and also a few commands for assuming poses. These are variables that keep track of the current position of the left and right eye and also the camera. These are the poses I've defined. These are limit definitions for the servos. So if the Jetson tells the servo to move too far, it will just ignore the command if it's beyond the limit. These are the pose definitions. Each row consists of a set of servo positions. So you see we have 8 columns in a row. I also added HDLC functions for decoding any incoming HDLC messages, HDLC framed command messages. I'm not using this from the Jetson right now, but I probably will in the future. These functions just initialize the camera gimbal to a neutral position. This is a function for assuming a pose. You tell it which pose ID you want, and it will do a lookup and set the goal position for each individual servo. There's also functions for moving the camera left, right, up and down. And there's an interrupt function. So when the controller receives a byte over the UART, it will just check that byte and look up against the set of known commands and execute that command. The setup function attaches the interrupt function, initializes the dynamic cells, and then it sets every servo in joint mode and assumes a neutral pose. And the loop function is trivial. It just continually updates the goal positions for each servo according to the state variables. Now we can try out the command. I've hooked the controller up to the PC and fired up PuTTY, which is a terminal emulator. So I have commands for moving the eyes left or right, up, down, up, and single commands for kind of a neutral position, sleeping, neutral, winking. And so forth. So I can just define new poses by adding a line of 8 servo positions. So now I can move on and hook it up to the Jetson and see if we can make the eyes track the faces that the camera detects. This is the Python code that's running on the NVIDIA Jetson. It's a piece of code that I found on GitHub, and I'll provide a link to the source code for this at the end of the video. It's called TRT MTCNN demo. The only changes I made to this, I've added a function that will adjust the robot camera according to where it finds a bounding box for a face in the image. So if the bounding box is off center, it will try to adjust the camera so that the bounding box is centered in the image. And since the detected positions can be a bit erratic on the pixel level, I've added some smoothing to this. So it's also running an exponential moving average filter. If the MTCNN detects more than one face, I'll just ignore the faces. So it will only respond if it detects a single face. And this is to make my code less complicated. So let's fire it up and see if it works. Okay, this is the MTCNN running. As you can see, it doesn't detect any faces right now. It's because only half of my face is showing. It's running at only 15 frames per second, so it's a bit slow, but since it's a prototype, this is okay. So I'll move back a bit and see if it detects my face and if the robot eyes are following that detection. So here you can see the robot spotted me. So as I move around to follow me, if it loses the detection, it will revert to the default position. Feels kind of weird to there it lost me. So, and it found me again. and if it stops detecting any faces, it will reset to the default position. I'll try from the other side. Move back, doesn't detect me anymore. So as a prototype, I'm quite happy, but I'll be amazed if it survives more than a couple of hours at Maker Faire. Okay, lessons learned. As you can see, the camera is hopping around a bit, and that's probably because of a feedback loop between the camera and the detection. The resolution of these servos within the angle that's necessary is too low, so it will overshoot. And I could resolve this by having a geared servo or a high resolution servo, and of course this means that the servos should also be quite a bit faster. That's one thing. It's been a really fun build. I learned a lot about mold making, casting, which are techniques I'm probably going to use in other projects as well later on. So I'll take this to Trondheim Maker Faire at 26th, 27th of August. So if you're in Trondheim, which is unlikely if you're not actually living in Trondheim, you'll be able to see it live for as long as it works. It will probably break down in a few hours. I'll also bring the static version. So, see you. Bye.